In this tutorial, we're going to take a look at the basics of work item attributes and how they're synchronized between dependencies in a PDG graph. We'll construct a simple network that cooks some geometry and uses Python script nodes to manipulate work item attributes during the cook. Let's begin by putting down a ROP geometry node. We'll configure it to use the embedded SOP network by toggling off the Use External SOP option. We'll also go to the ROP Fetch tab and set the cache mode to write files. Since we'll be recooking the node, that'll prevent PDG from detecting existing files and immediately marking the work item as cooked. Next, dive into the ROP geo and replace the existing network contents with a box. This will give our work item something simple to do when we finally go to cook the node. After returning back to the top network, right mouse click on the node and select Generate Node. Inside of a top network, it's possible to inspect the data on a work item by doing a Control plus middle mouse click on that item. For example, on this ROP geometry work item, the attribute pane shows a mixture of numeric attributes, a HIP file path, and some node paths. A work item attribute can hold primitive values like integers, floats, strings, or arrays of those data types. They can also store higher level string types, like a tagged file path or op path. Starting with Houdini 18, work items can store Python objects and native Houdini geometry as well. In our case, the item has a string and float attribute, a float array, a file path, and a few operator paths. Attributes like the HIP file will always render as a clickable link, which opens the file in the default viewer for that file type. PDG nodes will set attribute values when generating work items. Often those values are used to control the behavior of the work item's job, such as the frame range or ROP node path on this ROP geometry work item. Those values are fed to the script that cooks the ROP out of process or on the farm. It can also be the case, however, that attributes are added to a node solely for the purpose of supplying data to other downstream work items. If we wire a wedge node into the ROP geometry, we can use the wedge to create some random values. We'll add a random float called example, and a random integer called example2. Then, right mouse button on the node and click Generate. The attributes we added will appear in the panel. After generating the ROP geometry, all the values from our wedge can be found on that work item as well. When a node generates a new work item from an existing upstream work item, the new work item will have all the attributes from the original one, plus whatever additional data the node chose to add to the work item itself. Attributes added by the node will always take priority over any inherited attributes. A node will always overwrite any upstream attributes with the same name. For example, let's try adding an output parm attribute to our list of wedges. We'll make it a string, and we'll fill it with a garbage value that we don't actually want to use. If we generate the wedge node, we'll see the attribute appear in the panel. If we generate our ROP geometry and inspect its attributes, we'll see that it still has the correct output parm value chosen by the node. Attributes can also be set during the cook. This allows work items to write computation results or output files back to PDG. If we cook our ROP geometry node and inspect the work items after the process is complete, there's a new output file path that was reported by the job. Like the HIP file attribute, the output file will render as a clickable link. We can access cook time attributes downstream using a Python script node. For example, we can create a new float attribute with the upstream work item's cook duration, which can obviously only be known after the work item is cooked. Also, we can add a new string attribute with the upstream work item's name. By storing these values to attributes, we've stashed them in the way that we can make use of them downstream without having to find a reference to the work item again. If we cook our Python script, we'll see the attributes in the panel. The code in the Python script will run when the work item is cooking. You can think of it as the job of a Python script work item, even though it runs in the same process. We can then do some further processing of those attributes in a second Python script node. Technically, we could have used the same one we created initially, but this will serve as a nice example of how work items inherit upstream attributes added during the cook. The code first defines an output text file in the HIP directory, which we'll use to write data into. The $HIP variable is enclosed in backticks, so that Houdini expands it for us automatically. Our code then opens the file and writes the attributes from the first work item into it. Once that's completed, the code reports the file back to PDG as an output, so it's accessible from the attribute pane. Before we cook anything, go to the task menu and select Delete All Results from Disk. This will delete all work items and their output files. Then, right mouse button on the new Python script node, and select Generate. None of the attributes from our first Python script exist yet on this work item. In fact, they're also not even on the original Python script work item either. This is because, as mentioned earlier, those attributes are added during the cook, not the generate. We of course still want those attribute values to be available to our downstream work items. So before the second Python script work item cooks, it'll synchronize any attributes added to the first Python script while that item was cooking. This lets us safely access those values in our second Python script node, even though they didn't show up originally when we generated the item. The same principle also applies to output files, or attributes reported back to PTG by an out-of-process job. We can now cook our node, and once it completes, the attributes are listed for the work item. The output file produced by the second script also shows up as expected. We can click on that file to open it and see the values that we wrote out to disk. When syncing attribute values before cooking, work items will never overwrite their own attributes with upstream attributes of the same name. This is very similar to how work items will always use the values set by their node, rather than inherited upstream attributes. We can test that by adding an attribute create and placing it between our two Python script nodes. We'll add a new float attribute on the attribute create called duration, and give it a value of 10. Then we'll dirty the wedge and cook the second Python script. The first Python script has the same duration value as before. The attribute create has the value we typed in. The upstream value doesn't replace it because the node explicitly chose to set that attribute on the work item. Finally, on the second Python script, the duration is also still 10, since that value is inherited during the generate stage from the attribute create. That wraps up our introduction to work item attributes. The API for manipulating values, as well as additional information, can be found in the PDG Python reference.